In this video, we'll look under the hood at how JavaScript works. Some of what I cover here, especially around threads and event loop, might feel abstract right now. Don't worry about fully grasping it. I'm including it here to give you the lay of the land, so to speak. We'll come back to these ideas when we get to asynchronous programming in JavaScript. So let us start by talking about JavaScript engine. A JavaScript engine is a program that executes your code. Different browsers and environments use different engines. Chrome, Edge, Node.js, and Dino use an engine called V8, which was developed by Google for their Chrome browser. Firefox uses an engine called the SpiderMonkey, and Safari and Bun use JavaScript Core, which was developed by Apple. Despite using different engines, they all follow the ECMAScript standard, so your code behaves consistently across different environments. Let us talk a little bit about how modern JavaScript engine work. They use a process called JIT compilation or just-in-time compilation. It is a hybrid of interpretation and compilation. So when you work with a language like C or C++, you write your code and then you compile that and it translates that code into machine language, and then you run that executable that the compiler creates for you. When you work with a language like Python, what happens is that Python has an interpreter, and the interpreter basically reads your code line by line or a statement by statement, and it executes it. JavaScript was originally an interpreted language. JIT compilation is a sort of a modern version that brings some of the features of compilers and mix those with interpreters. So what happens basically is that the engine starts executing your code, and as the program runs, it identifies so-called hot code or hot code path, where these are the areas that your code runs frequently, and it compiles those to optimize machine code. And so it does that so that your program runs faster, and it keeps optimizing as the program continues. So this sort of addition or this improvement over the years made JavaScript program to run more efficiently. You get the immediate execution without having the compiler step, but you still get a reasonable performance. Let's talk a little bit more about JavaScript runtime environments. So a JavaScript engine by itself only understands the core language, things like variables, functions, objects, control flow, and all of that. A runtime environment is what adds other features or other possibilities to the JavaScript language, and it basically is a set of APIs, application programming interface, that allow your JavaScript to interact with the environment that it runs in. So the engine knows the JavaScript syntax, the runtime knows how to talk to the browser, to the operating system, to the network, to the file system. So originally, JavaScript was built for the browser, and so the environment was just understanding the browser. And these are the things like being able to manipulate the web pages, being able to make API requests to servers, work with the storage of the browser, and a number of other features that are available and specific to the browser. Now, once programs like Node.js enabled and brought JavaScript to the server side, they have provided other APIs. So then through a program like Node, you could talk to the file system, you would be able to speak to the operating system, do process management. Now, in most cases, this is not really that important for you when you write code, but there are some cases that this becomes important. For example, if you are in the browser, you would not have access to things like file processing or the operating system. On the other hand, if you're writing code on the server side, you don't have access to some of the specific APIs that the browser makes it available to you. Okay, so let's move on from this and talk about something else, which is an important characteristic of JavaScript. And it is a little difficult to speak about this without having sufficient background. So I'm going to try my best to explain this in a way that it feels that it feels not too foreign to you. So JavaScript executes on a single thread. So what does this mean? If you're coming from languages like Java or C++, those languages actually they can run multiple threads at the same time. Now, usually in your earlier exposure to programming, you don't get to explore those features of those other languages. So I really doubt that if you are coming here from like CS1, CS2 background, maybe you took 2-3 different courses in programming, I doubt that you got to explore writing parallel program, concurrent threads, and explore these features of a programming language like Java or C++. However, the way you can think about it is that threads are like workers, right? So Java can have, let's say, multiple workers doing different tasks simultaneously, and that brings some advantages. For example, if you do several tasks at the same time, the program will run faster, right? Because you get more done in the same amount of time. So think about it that way. On the other hand, JavaScript just has, let's think about it, it just has like one worker. You can only do one thing at a time. Let's put it that way. So with one thread, only one piece of code runs at a time. So your code runs line by line, start to finish, in the sequence that we define it, which is the way that you've been writing code in, early programming classes, right? So even though, like, if you're coming from Java, that Java allows you to write multiple threads, you have been writing code in a single threaded fashion. And so why is this important? This is particularly important when you work with graphical user interfaces like in the browser, right? You have a web page that has buttons on it, forms on it. There are a lot of different things going on. And programs that have graphical user interfaces, they are typically event driven. What it means is that you like click on something and like you click a button that is an event, and as a result of that event, something should happen, right? So say you're on a web page and you click a button that fetches some data from a server. The network request can take some time. It could be in order of milliseconds or even a few seconds. And if JavaScript, now given that it is single threaded, right? Like if JavaScript would have waited for the server to respond, the page will freeze. Like if you are on YouTube and you're trying to watch a video, right? And then the YouTube is constantly streaming the data, the video from a server, and you're looking at it. And every time it kind of goes about getting a little bit of that, your video will stop and the whole program will freeze. Or if you go and, for example, while watching a video, scroll through the comments or click on a like button or see the recommended videos on the side, or if you have the chat panel open up on the side. So anything else that you do, if like everything was being run sequentially, one process would block another one. So if like you click on a button, you wouldn't be able to scroll. If the video is running, you wouldn't be able to like scroll through the comments. That obviously that's not how the web pages and web apps work. So it seems that somehow this is solved. This issue is solved. So the way JavaScript goes about solving this problem, their non-blocking solution is that instead of like waiting for a process that can be time consuming or computationally expensive, JavaScript sort of puts that on a back burner. It's as if it happens in the background. It's not really that JavaScript does that. It's the JavaScript engine with the help of its runtime environment makes that happen. So like if you're in a browser, what happens is that if you're going about running some code that could potentially be time consuming and it would cause blocking other operation, you would get help from the browser to run this in the background on a back burner. And then when that process is done, the browser will sort of come back to you and be like, hey, okay, this thing you asked me to do, I'm done with it. Here's the result of it. What do you want to do with that? This process that I described for you, it's called asynchronous programming, right? And we're going to spend some time going over asynchronous programming in JavaScript. It's one of those things that's going to be most likely very different from how you are used to program. So to add a little bit more into this is that I'm going to talk about the event loop. And again, this is going to come up when we get to the chapter about asynchronous programming. But this notion of, hey, let's put something on a back burner, let it run, let it cook, and when it's ready, we go back to it. There's a mechanism built into JavaScript engine. It's called the events loop, and this is responsible for coordinating this asynchronous operation. And we're going to be covering this in a chapter dedicated to asynchronous programming.